so fast that for us it's instantaneous, and sound travels at 300 meters a second. So for every 5 seconds, the storm is a mile away. So we found, what we found is that if we decouple the time of arrival differences of the ripples and the sound, so that the ripples make it sound like the male's calling from farther away, even though we keep the amplitude the same, the responses of the frogs go down, as if they know that this is a rival male and he's very far away. So in summary, what we've tried to do here, we've tried to look at the evolution of these sexually selected traits. Unlike most other approaches to this, we haven't been emphasizing the adaptive advantages or disadvantages to the females in making certain kinds of choices. We have studied this, and we know that there are some adaptive advantages for females to do what they do. But on the other hand, what we're also finding is by having some fundamental knowledge of how the animal acquires information about their males, and the algorithms that they use in making comparisons between males, we think and also how they take information from different modalities of a courtship signal and put them all together, we think is giving us a much better insight into understanding how these sexually selected traits evolve. And what we emphasize again is that to understand the evolution of sexual beauty, we need to understand the sexual aesthetics that drive the evolution of this beauty. There's tons of people to thank in these studies. Rachel Page, who has an adjunct appointment here. Rachel does all of the back work. Ryan Taylor is the person who does most of the RoboFrog work. Pam Farris has done a lot of the neurobiology, not all of which I talked about. And then Walt Wilzinski and Kim Hope are other people who are very important on the neuro end of this. So if there's any time for questions, I'd be glad to answer them.